In this video, we will solve Mohr circle problems. We will do stress transformation and principal stress determination with the help of Mohr circle. In the first problem, we have a stress state. Sigma x is 200 MPa. Sigma y is 100 MPa. And we have a shear stress minus 75 MPa. Question is, draw the Mohr circle in the plane. Second question is, find the principal stresses and the angles of the principal planes with the x-axis, and find the stresses after a stress transformation by 30 degrees rotation. We know that, well, for stress transformation, we have formula. So when we put sigma x, sigma y, and tau xy, we can determine the principal stresses and their angles, their orientations. But in this curve, we will show how to do it with the help of the Mohr circle. To draw the Mohr circle, you have different techniques. The first one is you can determine the sigma m. This is the average normal stress, and this value corresponds to the center of the Mohr circle. And using this formula, you can determine the radius of the Mohr circle. So you put the center and take the radius and draw the circle. That's the easiest way to do it by mathematics. Or you can do also the following. You can draw your axis, take the points. For example, this surface has a sigma of 200, a tau of minus 75. These are your sigma and plus tau axis. So if you call this surface A, well, it will be represented by a point 100, 200, minus 75. This may be point 200 and minus 75. Okay, the other surface, I mean this surface, let's call it B, it has sigma equals to 100 and tau plus 75. So when you draw this point B, that is 100 and plus 75, this one will come up like this. Then you can draw the Mohr circle by connecting these 2 points. This is point B, and finding the center and drawing the circle going through these 2 points. You see, here you have calculated the center and the radius. Here you have used the 2 points to draw the Mohr circle. Well, you can do both of it or do one and check with the help of the second technique whether the circle is correct or not. Now we have our Mohr circle. First question, principal stresses in the plane. So principal stresses are on planes where tau is 0 and the values of the stresses are maximum and minimum. These are the 2 points, B and A. How do you find the values? So we know that is the 750. That one is your radius, and the radius was determined as 90.1. So the first principal stress is the average plus R gives you 240. And the second one is the average for the center minus R, that will give you 59.9. These are the two principal stresses in the plane. Let's find the orientation of the principal planes, the angles. So I know the reference plane, this one, that was 200 minus 75, and this plane, and it's represented by this point. Well, in order to reach the first principal plane, I have to rotate this surface by an angle phi1. On the Mohr circle, it corresponds to 2 phi1. And then what I need is to determine this phi1. This phi1 is a rotation in the clockwise direction, so it is minus. So let's take this triangle. Well, this is 2p1, and this one is also 2p1, and you have now this side is 2 times 75. This one is 200 minus 100. So if you take the tangent of 2p1, you see that phi1 can be determined, and if half of it will be your phi1 value. Now, what do I know now? Well, if this is my starting reference orientation, I have to rotate clockwise by 28.2, or you call it minus, considering the direction of the rotation, and that will be my principal plane A. About the next one, I need to determine now, starting again from the reference plane, to reach the other principal plane, I have to rotate by 2 phi 2, and that is 2 phi 2 is 180 minus 2 phi 1, or phi 2 equals to 90 minus phi 1, and as you see, phi 2 equals to 90 minus 28, and that's 61 degrees. So if this is my orientation, which I take as a reference, when I rotate clockwise by 28, I reach the sigma A. If I rotate from this point by 61.85, I reach the second principal plane. Now, well, there was another question. What happens after 30 degrees rotation anti-clockwise? So this again is my reference, and I rotate this axis to x prime by 30 degrees. We know we have our stress transformation equations. You can put the known values and calculate these new stresses. But you can do it also with the help of the Mohr circle. So as you see, this is my point Px. Well, it had 200 minus 75. Now I need a rotation 30 degrees. So on the Mohr circle, I have to rotate 60 degrees. So as you see, this I already known, and now I can determine this beta value. This beta value is 180 minus P1 minus 60 and can be determined very easily. Now I need to determine the stresses in the new orientation. Well, these are the coordinate of this point, sigma x prime and tau x prime y prime. So you can, as we said, you can use these relations, or you can determine this angle beta. Well, we have it already. And for example, to find this coordinate, all you need to do is you have to take sigma m minus this value. This will be your coordinate of px prime. So how do you do it? Well, this length is 150 sigma m, and we know that this distance can be easily calculated by r times cosine 60. So minus r times cosine 60, and this value is 110. Next, I need to calculate the next coordinate of the point px prime, that is this coordinate. Well, how do you do it? Well, it's much easier. You have r, you have beta, and this value that x prime y prime corresponds to r times sine beta with a minus sign, and that is your new shear stress. Well, now you can do the same for this surface, and you rotate it. You will have this point is rotated to this point, and doing similar calculation, you find the stresses in the new surface, which has a normal y prime. In our next problem, we have a pipe. Diameter 100, wall thickness is 10, diameter is 100, that is 10, so the inner diameter will be 80 millimeters, and acting normal stress, which is along the axis of the pipe, and a moment also along the axis of the pipe. So when you take your hand, right hand, place your thumb, you will see that this type of a moment is torque. So you will have torsion. And so for this case, the Mohr circle for a point on the surface has to be drawn, and the principal stresses and the maximum shear stress on the surface has to be determined, and also the orientation of these planes. Next, well, we know since we have a normal force, it will create a normal stress, and the torque will cause a shear stress. Let's start with the normal stress. Well, this is my actual force, and this is my area of the section. 150.3 is the uniformly distributed normal stress in the pipe. Next, we have a shear stress, and it is maximum on the surface, and we know tau equals to m times c over j, polar moment of inertia. This 2 you can call also w, and using this formula, put in the numerical values, you find that tau is 79.8. So in this case, I have a sigma z 150, which is this direction, and I have a tau yz 79.8. And in the radial direction, that is this direction, there is no normal stress. Okay. Now I know the stress is for a point on the surface, the sigmas and the taus. So in order to draw the Mohr circle, I can determine the center of the circle. This plus this divided by 2 gives you 75. So you can continue by taking the relation for the radius of the Mohr circle and determine its value and draw the Mohr circle. But we will do the drawing in another way. Over here, I am determining the center and then one point. Which point? Well, maybe this point, 150, 79. 150, 79. Now I know the center and one point of the Mohr circle. I can easily draw the circle like this. Okay, so now I have my Mohr circle. Next step is to determine the maximum shear stress. Where are the maximum values? Well, this is tau max, and that one is tau min or the tau max in the other direction. Okay, so well, this corresponds to the radius of the Mohr circle. And how do you determine the radius of the Mohr circle? Well, you can take the triangle, well, this one, okay, and in this triangle, this is 79, and this is 150 divided by 2, okay, 150 divided by 2 square plus 79 square will give you the radius of the Mohr circle, which is also maximum and the minimum shear stresses. So we have these two values. Next, what about the principal stresses? So what you have to do is you have the middle, that's 75. So if you go plus R, and R is already determined, and minus R, you come to this point, plus R, you come to this point. You can determine these two values. So you see this is the center divided by 2, that's 75, and that was already determined as the radius. Next, we know that these are the principal stresses in the plane. There is a third principal stresses, which is perpendicular to the plane and its value is 0. So when you want to name these with proper subscripts, you have to take the maximum of this one as 1. This will be 2, and this will be principal stress number 3. 1, 2, 3. These are my principal stresses. Well, we will notice that the order of the principal stresses and that they are properly subscripted is very important for the failure analysis in strength of material. What about the orientation of the principal planes? Well, this is my x-axis, and the stresses on this plane are represented by point Px. Well, the first principal stress lies over here. I have rotate anti-clockwise by an angle of 2 phi1 in order to reach this principal plane. So in reality, I have to rotate only by phi1 in order to reach the principal plane. So I have to determine this value. 2 phi1, you can see this angle over here, 2 phi1. So you can take tangent 2 phi1 is 2 times 79 divided by 150.3. Okay, there you can determine 2 phi1 and phi1 is 23.4. That means when you rotate your coordinates or your x-axis by 23.4, you reach the normal of the principal plane. What about the next principal plane? It lies over here. This again is my reference, and then I have to rotate like this, positive direction, and let's call this phi 2, and 2 phi 2 is 2 phi 2 is equal to 2 phi 1 plus 180, phi 2 equals to phi 1 plus 90, and the value is 111. So if you start from here and rotate by 111, you come to this surface, which is your next principal plane in this x in this two-dimensional case. Okay, orientation of the maximum shear stress planes. Let's take this point and here, starting again from the reference, you have to rotate by 2, let's call it phi 3, and 2 phi 3 equals to, I know this value, 2 phi 1 plus 90, so phi 3 equals to phi 1 plus 45, it's 68. So you can calculate this angle in the negative direction, let's call it 2 phi 4, and as you see, it is rotating in the negative direction, and the result is again 23 minus 45, it is minus 21.6. So as you see, we have determined the orientation of both maximum shear stress planes. Okay, in this video we have solved two stress transformation and principal stress maximum shear stress determination problems, and for the solution of these problems we have used the Mohr circle. Thank you for listening.